excited. Cannot wait.
Okay, without further ado, I think Mr. Ken is in Zoom right now.
Okay, awesome.
Yes, good morning. I'm sorry, my connection here is not stable, so I was somehow thrown out from the Zoom, so apologize for the inconvenience. All right, thank you, Emil and Arthur. I hope my voice actually could be heard clearly. Good morning, everyone. So welcome to the fourth plenary session of Summer Camp Engineers 2022. And it's my pleasure to be the moderator for this morning sessions. So for these sessions, the topic will be big data and data mining, the importance of data in Industry 4.0, which will be delivered by Mr. Bambang Satrijotomo. Actually, the MCs already greet Mr. Bambang, but I haven't greet, so I would like to take this opportunity to greet Mr. Bambang. Good morning, or good evening, actually, Mr. Bambang in US. How are you today?
I'm good, thank you.
Great to hear that. Again, I would like to thank you because you managed to spare your time to share your experience and knowledge with us this evening, actually, at your time. So thank you again very much, Mr. Bambang.
You're welcome.
All right, so before we start the session, I would read the curriculum vitae of Mr. Bambang. So Mr. Bambang received his bachelor's degree in industrial engineering from ITS. He received his MBA degree in finance major from Washington State University and a master's degree in information management systems from Harvard Extension School. He started his career as an engineer at Ericsson and continued as a solution architect, cloud and OSS still in Ericsson. In 2018, he moved to Microsoft as an Azure Big Data Analyst support, then changed position to Azure Inside Tech Solutions Professional and Azure Cloud Solutions Architects in the next consecutive years. His current position is Customer Engineer at Google. I think it's an impressive experience, working experience of Mr. Bambang, and I'm sure everyone is looking forward to hear the experience sharing from Mr. Bambang in this morning's session. Again, before we start, I would like to inform you that the presentation time will be around 45 minutes, and we'll continue with the Q&A session for 10 minutes with the participants. And for the participants, as usual, you may ask your questions at Slido through the link that will be provided by the committee. Yeah, Mr. Bambang, you may now start the presentation, and the screen is yours.
Thank you. Let me share my screen and let me know if you can see it. Are you able to see my screen? It says big data and data mining, or not?
Yes, Mr. Bambang.
Sorry, is it yes or not? Let me stop share again and let me share. Number 2, desktop number 2. I'll share the desktop. Right. Are you able to see my screen? Thumbs up, thumbs down?
Yes, Mr. Bambang. It's clear.
Oh, thumbs up. Cool.
Okay.
All right. And by the way, just one minor correction about my biography. So I'm still working on my master degree with the Harvard. So I hope that I can complete by next year, hopefully. All right. So our topic today is a big data and data mining, and the importance of data in Industry 4.0. And 1 second. Yep. And before we continue, I already prepared introduction of myself, so it's like a redundant, but that's fine. I'm Bambang Satrijotomo. I work for Google currently, and this is my picture 2 weeks ago when I visited the Chicago office. So I live in Dallas Metroplex area in Texas, Dallas-Fort Worth Metroplex area in Texas with my family. I have 4 kids, 2 daughters and 2 sons. My eldest daughter now is a senior in University of Texas at Austin. She studies neuroscience, and hopefully she can graduate next year. I graduated from ITS in 1997, and since then I work in telecommunication industry. I became the SME or subject matter expert in one of the Ericsson products. So I travel around the world, working in different countries, different projects. And in 2011, I got an offer to join Ericsson US. And then since then, I've been living in Dallas since 2011. Around 2018, I switched career from telecommunication industry to the IT by moving to Microsoft. And last year, I was lucky enough to be able to join Google as the enterprise cloud solution architect. So that's about me. Let's go over our agenda today. So first, we'll talk about Google and why Google, because when you're talking about the big data, Google is one of the pioneers in this field, and we'll see why. And then we'll go over to the big data and mining quickly, go over some definitions. And then next, we'll discuss some of industry applications. And lastly, we'll go a bit more deeper into the manufacturing. What are the current manufacturing industry challenges and how big data analytics can help to solve those challenges, right? All right, so let's go over the first agenda for today. What is Google? I think everyone knows what is Google, and even in Indonesia, we call it Mbah Google, although that's misleading because Google was founded in 1998. So Google is still young. It's not Mbah yet. So Google was founded in 1998 by Larry Page and Sergey Brin, and both of them are the students at the time in the PhD students in the Stanford University. So at the time, Larry Page was considering Stanford, that's on the San Francisco area, for grad school, and Sergey Brin, a student there, was assigned to show him around, like maybe onboarding buddy or mentor kind of thing. And then by some accounts, it was told that they both disagreed about nearly everything that they discussed during the first meeting. But then they became they struck partnership, and then they're working from their dorm rooms. They built search engine that they call it Backrub. Then they later rename it as Google as we know now. So you see, when you have someone you disagree with everything that he or she said, it could be that he or she becomes your good partner in the future, right? Because maybe that you complete each other. And going back to the Google, the main business of Google can be seen here. One is the search engine technology, obviously. Second is online advertising. That's the main business, main revenue for Google. And third is cloud computing with the Google Cloud, and that's where I'm working for. And then, of course, there's Android software, hardware, and so on and so forth. All right, so one thing that I learned when I joined Google is how the company vision and mission is so accurate with what they are doing and what they are trying to achieve. I've seen sometimes I've seen companies' vision are so broad and vague, or maybe sometimes it's just so narrow. But to me, Google's vision and mission, to me, is just mission statement. To me, it's just spot on. So Google's mission is to organize the world's information and to make it universally accessible and useful. So let's unpack this one by one. So to organize the world information, this at the beginning of the Google, when they're still running from the garage, this is very ambitious, right? You want to organize the world's information. It's not just the a company's information or a country information. It's the world information, right? And then to make it universally accessible and useful, meaning that once you get the data, once you collect the data, once you organize the data, it's not that you put the fence around it, you put the subscription, you put the charge on it, rather than you make it universally accessible. Everyone can access it. No one has to pay Google search. You can search anything in Google search. There's no limitation how many times you search a keyword in Google. everyone can do that. So that's democratization of information. And of course, information or data will not be, although it's accessible, it needs also to be useful. It needs to bring value to your life. Otherwise, data information can be garbage, right? And garbage in, garbage out, right? So in Google's, we talk about the big data. Why? Because since the beginning, with the Google search, we continue to have to add billion users applications, meaning that, for example, Google search, I think billion of users every day on the planet Earth are using Google search. And can you imagine how big the data generated by that? And not only Google search, we have Gmail, Google Maps that can help you to find the shortest path to the destination, right? And then you have YouTube to learn do-it-yourself things, learns coding or data science, for example. You have Android, you use Android in your phone, you use Chrome to browse the information. You have a Google Play, you have Google Drive to store your documents. You have Google Photos to preserve your memories, and so on and so forth. There are 9 billion users application, but I would argue that there's the 10th application, billion users application, which is Google Cloud, because indirectly we support billion of users, meaning that our customer is Google Cloud, supporting in total altogether supporting more than 1 billion users. All right, so enough about Google. Now we go to our main menu, big data and data mining. So anyone would like to volunteer to give definition what is big data and data mining? Anyone? Don't be shy. No? All right, so let's go to Wikipedia. So it's not my definition or Google's definition, it's Wikipedia, right? So here, big data refers to the data sets that are too large or complex to be dealt with the traditional data processing application software. And big data commonly associated with 3 V's characteristic: the volume, the variety, and velocity. So the volume is the key characteristic of the big data because of its scale. The volume of data that is available for collection by your enterprise from a variety of devices and sources. In the beginning of the session, I saw the thriller with the IoT and so on and so forth. So IoT, Internet of Things, are the supplier kind of thing of the big data, right? Because it generated a huge number of data from its sensors. Can you imagine one smart factory with engines which are controlled, which are monitored with the sensor? How big the data that's generated with that sensors every day, right? Only from one factory. Also, cars these days, there are more computers in the cars than the mechanical, right? So each cars, especially the latest, the newest car with a lot of microprocessors, every day every seconds it sends or even millisecond, it sensor the environment, the temperature, everything to make the engine, if it's an engine ICE car, to make it more optimum. And then the variety. The variety refers to the formats that data comes in, such as email messages, audio files, video, sensor data, and more. So from structured to unstructured data. And then the third character is the velocity, the speed, right? So big data velocity refers to the speed at which large data sets are acquired, processed, and accessed. So in terms of the data engineering technology, we know that there are 2 scenarios. We classify 2 scenarios: batching and streaming. So analogy of the batching and streaming is like when you try to move water from one point to another point, right? From one city to another city, for example. In a batching, the analogy is like you transfer the water using the trucks, using the lorries, right? You have the tanker, 5,000 liters, for example. You put the water in the tanker and then you move the tanker to the destination. That's the batching. But streaming is like you have a pipe, right, from one city to another city, and then you put the water in the pipe to transfer the water to the destination. That's a streaming, and both of them, batching and streaming, are used in the industry use cases. So it's not like only streaming or only batching, but depends on the use cases, because streaming normally is more expensive to set up because it's always 24/7 normally, right? It's always on kind of thing. Well, we have discussed the three characteristics. Actually, sometimes people are also define the fourth characteristic, which can be variability, or sometimes the veracity. How accurate is the data? Because if the data is not accurate, data is somehow falsified during the process, then it's not useful anymore, right? And then data mining. So data mining involves data mining is the process of sorting through large data sets to identify patterns and relationships that can help solve business problems through data analytics. So this is like the next stage. After you collect the data, either by your sensors, your devices, right? You collect the data, huge data, big data, but then what are you going to do with that data? Data in itself doesn't create any value for an organization. Only when you can get the insight, when you can solve the problem, solve the questions using the data, then the data becomes creating the value, right? And then the common classes of tasks in the data mining includes the anomaly detection, clustering, classification. I think also regression is part of the data mining, right? And then because we're talking about data mining here, let me throw also another couple of more definitions: data analysis and data analytics, right? So some definitions, according to some definition, it is that data mining is part of the data analysis, right? And then the data analysis itself is part of data analytics. So we'll talk about the data mining, and data analysis is a process of inspecting, cleansing, transferring, and modeling the data with the goal of discovering useful information. So as you can see, this is like a overlap definition with the data mining. And also data analytics. Data analytics, sometimes it's defined as the larger multidisciplinary field that the goal is also to formulate, to support the decision making in an organization based on the inference of the data. And in Google, we normally just lump all this together into data analytics terminology. So it's data analytics. All right. Then quiz for you. So should I follow the data or my instinct? I think you know the answer. So you can you can use your instinct for your personal, your daily decision making, but for organization, when it comes into the budget, financial budget decision that involves the cost, you cannot do instinct. You have to justify your decision. When you allocate resources in this project or in that project or in this area in that area, that all involves cost. And you should be able to justify that decision by the data, right? Okay. Let's go to the second topic agenda today, industry applications. Right. So in the I take one example here in the retail business with the inventory problem. I think as an industrial engineering student, you are all familiar with the inventory problem. And I remember when I was a student, there's I think there's one subject, one course for the inventory management. We have a formula to calculate the optimum inventory level, right? And this is also not only in the factory, right? Just in time inventory kind of thing, but it also common problem in the retail business. It's a Goldilocks problem when it comes to inventory. Don't stock too much, but don't stock too little. Because you know what? Where inventory is stored in the retail business? In the warehouse. And then if you have a brick and mortar shop, let's say, I think in Indonesia it's Alpha Mart, Indomart, but here in US we have 7-Eleven, we have CVS, Walgreens, and the bigger one like a Walmart. So they have a limited space. Now, when you allocate the space, the inventory space, which is your warehouse for the store, you have to be as optimum as possible, because space is cost, space is money, right? If your stuff, if your products are not moving fast enough, then you don't want to allocate too much space for this product, right? So, and this problem gets even more complicated when you have a million of products in a one store, like maybe not million, but huge number of products, like say for the Walmart Supercenter. It's a huge store for every store, they call it hyper store kind of thing. And also, when you compare one store in one location and to another store in another location, they could have a different spending pattern. Maybe the store in my area, I live in a suburb of Dallas called Plano. So maybe the Walmart in Plano, they like more groceries, but maybe the Walmart in the Frisco, for example, that's my neighboring city, maybe they spend more in the beverages, for example. So not only that we have to build a model, right? We have to make a decision on that, but it's also we have to customize, to tailor the model to each of the category, right? So now with the potential million of products for data science and engineering team to create the multi-millions of forecasts is one thing that's already complex, right? But also to procure and manage the infrastructure to handle the continuous model training and forecasting, that's another problem in itself, right? You cannot, with this big data analytic, you cannot run the modeling in your PC. Your PC will run 24 hours for years before it can spit the model, right? So the solution here, there's a blog article, a technical blog article that you can Google. So I put the title at the bottom here. So the solution here is to build a time series model, and I'm sure that you're already very familiar with ARIMA, autoregressive integrated moving average for the forecasting, and this to forecast the demand of multiple products, automate the modeling, and then to create a dashboard to visualize the forecasted demand, and set up scheduled queries to automatically retrain the model on regular basis. So let's unpack this one by one. So we built a time series model and we use BigQuery. BigQuery is Google product. Then create a dashboard. And why you need to have the dashboard? Because the dashboard is again, You can create the best modeling in the world, right? But if you don't show it, if you don't strategically show the result to the business users, then it will go for nothing, right? In a company, there are always their business users, decision makers who are not technical. They want to see the data. They want to see graph chart and everything that support the decision making. And this is why you need to have the dashboard. And normally, when you create a dashboard, that's with what we call it is business intelligence tool, BI tool, like Power BI, like Lookers, like Google Data Studio, and so on and so forth. Basically, transform the data into something that more discernible, right? Picture it doesn't work. And then the next is to set up scheduled queries to automatically retrain the model on regular basis. So why we need to retrain the model on regular basis? Because the answer is that it could be that the data that we base the model on already obsolete. Maybe the store in Plano, I live in Plano, right? Maybe people in Plano, the spending pattern 6 months ago already different from the spending pattern now, and maybe different from spending pattern a year later, right? And we don't want to be the data becomes drifting, becomes obsolete, less accurate. So we want to retrain in a regular basis. And also it could be that, well, next time, I mean, in the future, the marketing team, they think that, hey, I collected new information, new variables, new columns in my data. I want to see how these columns, these variables impact our model. So what you need to do, you have to retrain the model, right? And it has to be automatic. It cannot be manual because just too much effort in it. So you have to set up the automatic job for that. All right. So that's the retail business industry. And then also in the finance, in the credit card fraud detection. So now we are in the cashless society. I almost never bring any cash in my wallet. I only bring my credit cards. I pay everything using credit cards, and even sometimes I pay using my phone because I stored my credit card information in my phone, right? That brings another challenges. So it's very common to be, I mean, we heard about credit card fraud detection, credit card fraud, because if anyone can get my credit card number, expiration date, and the 3 digits of CVV, right, on the back of the card. That's the three numbers, and they can get my full name and my address. Then they can use my credit card to purchase almost anything in the internet, right? So that's a fraud because I'm not the one who did the purchase, right? And it is important for the credit card company to identify credit card fraud very early in the process. Why? Because typically, whenever there's a fraud, somebody is using my credit card to buy a car, maybe, then I can say it's not me. I'm not the one who purchased that. You see, at this date, at this time, I'm not in that car. I'm not in the car store or what. And typically, whenever there's a fraud, customer are not liable. Customer is protected, but somebody has to pay for that, right? Either fully or either half or whatnot. So normally it is the merchant or the bank who issued the card that have to pay the bills, right? So it is in the bank's intention to reduce this risk as low as possible because they don't want to pay for the fraud, right? So this is the actual business problem for the banks. They want to solve the fraud, the credit card fraud early in the game, right? That's why here put that it has to be real time, actionable alerts. So when it's real time, when there's a keyword real time, then we know that it's a streaming, it's not a batching, right? So here on the right, this is the kind of the architecture of the solution in Google Cloud. Don't worry if it's looks confusing for now, but the thing is, the thing to understand here at the high level is that you have the point of sales to fit the model here, and this model here basically will determine based on signal, based on various variables, let's say value of the product or service purchase, location of the transaction, type of the vendor, etc., etc. So that fed into the modeling to determine if this transaction is approved or not. So as you can imagine, when you swipe the card, you want to get the information, you want to get this approval as quickly as possible. Seconds, less than second, if it's possible, right? So all of this process to determine if the transaction can go forward or not will need to be completed in a very quickly, right? So, oops. So again, this is the this is the business case for the cloud computing, because in a cloud computing you have the I would not say unlimited, but the ceiling, the limit is very, very high, meaning that, let's say this is the, this is the I don't know, like Lebaran, for example, when everyone is swiping the credit cards, everyone is purchase something, right? So the system, when it, when there are so many transactions, right, fed into this solution, then the solution should be able to scale, right? So that if the system doesn't scale and it's blocked the transaction, for example, then the companies will the credit card companies, the bank companies, they will lose income, right? There's opportunity lost. They don't want to have this problem, so they want to have this system to be able to scale as much as needed, and then when the Lebaran or the big days is over, people going back to normal, then the whole system will scale back to the original size, so that they don't have to pay for the infrastructure to huge infrastructure. It has to be elastic, it has to be scale up and scale down automatically. So that's why this solution needs to live in a cloud. You can do it and on a prem. You have the data center kind of thing. You buy the servers and then have this scale. But when you have you have your own infrastructure, servers, storage, normally it's the limit is not that high compared to if you are going to the cloud computing, right? Okay, and also I put the reference to this scenario. You can Google later on. See, Google. So everything in life now is Google, right? I remember when I graduated in 1997, it's so hard to find the information. I had to go reading the scriptsy, right? The final projects, previous year's final projects, or I have to go to the library to read all the books. Now everything is Googleable. So yeah. Okay, so we have the last section of presentation today, manufacturing industry, right? Now, as the world emerged from the pandemic, there are 6 major trends in the manufacturing industry that drive the major transformation. from the Google perspective. First trend is the customer digital expectations. I think we all know that during the pandemic, people are working from home. Students have everyone homeschooling. So I remember very well that that time I have 4 kids, right? So all of them are at home, studying from home. So each of them needs to have the kind of environment, room kind of thing so that they can focus to the study. And I am myself, I have to continue working from home. So internet is the must. I mean, if internet is down, then it will be disaster, right? So even at that time, I have 2 internet providers. I subscribe to 2 internet providers at home, so that if one internet is down, then you still have another internet provider. So with that experience, that now we're thinking that, hey, it's possible to work from home. Companies that think that it's not in the past that, well, working from home is bad, now they're forced to work from home, right? And then they start to seeing the benefit of working from home. Yep. And then same with the customers. So customers now overwhelmingly prefer digital enhanced engagement channels. And even for B2B, not only B2C, not only business to customers, like like in the retail industry, but it's also B2B, business to business. Because when they have the digital engagement, it's easily trackable, and it's all convenient, right? And you can automate a lot of things with the digital engagement. But at the same time, they also expect the level of personalization. So digitalization doesn't mean that everyone will be the same. We want to have the also personalization. We want to have the immersive experience and the logistic that they are used to from the omni-channel retailers. So this is the challenge. Like it or not, the companies, the manufacturers, they need to have the to cater to the customer digital expectation, right? And then also IoT, Internet of Things, is everywhere. IoT is becoming prevalent everywhere, not just on the consumer devices. Like now we have a smart washing machine, smart fridge, smart thermostat, smart oven. Everything is smart just because it's connected to the internet, right? Not only our phone, now everything connected to the internet. And why it's smart? Because now in the past, without the internet connectivity, when an appliance, for example, or electronic device needs to do something, all the brain processing will be local in that device, right? So you have to, when you expect a lot of processing in that device, then you have to have the very powerful machine. But now you can offload that decision making to the internet, to the cloud, right? So you have washing machine, you have AI. It could be that the washing machine itself may not have the AI processing, AI modeling, but it can connect to the internet and gets the decision making inference from the internet. Like you have a Google Maps in your phone. If you don't have internet, if you shut down the internet connectivity in your phone, can Google Map point you to from one point to another point? It's not, right, because the routing functionality is not running in the application itself. It's running in the cloud. It's running in a Google server. It sends the request, hey, I want to go from point A to point B, and send it to the cloud, to the processing server, and then it replied with this, hey, you have to go through this street, to this street, and to this street, and you will reach your destination in say 30 minutes kind of thing, right? So IoT is becoming prevalent everywhere, not just on customer devices, but also on industrial tools and machinery, right? So manufacturers are designing for smarter and connected products. I remember in my previous company, I have a customer who is the fishing companies. So they have boats, they have ships for ship, sorry, not shipping, fishing. They have boats for fishing, right? In the, I think it's Atlantic Ocean, right? And they have sensors, IoT devices in every part of the boats, in the engine, in the cooling storage facility for the fish that they catch, and everywhere. And because of course the boats are on, the ships are in the ocean, right? So there's no cellular signal, there's no Wi-Fi. So they use satellite to upload the data. And then from their office, from their headquarters, they can see, they visualize each of the ship, where's the location of the sensor. They can see the data. Hey, this engine temperature is this Celsius, it's this Fahrenheit. The temperature of the cold storage is this. The RPM of the engine is this 1,000 per minute, that kind of thing. So they now, with this data, that they can run predictive maintenance, right? So they can see, they can build the model, and then they can fit this data that they collect every day to this modeling, and to see, I think this engine will break down soon, so let's better to call the ship back to the dock before it's stranded, right? And then it's easier to predict the MTBF or whatnot, that kind of thing, so that their operation is more efficient, right? And then I also see the in the one use cases where you put in the agricultural industry, you put sensors on the ground. I mean, for the acidity of the soil, to also the dryness, of the soil, and so on and so forth. That all collects the information that is useful for the farmers to decide if they need to increase the watering or reduce the watering, and to put the more fertilizer or not, and so on and so forth. And because it's in the farming area, it's urban, very far from anywhere, no cellular signal again, then you have drone that collects the data that circling around the on top of this farming area, maybe several times a day, to collect the data. This is like a batching, that it's not streaming, it's like a batching, because you run it one, okay, you collect the data, you run it again, you collect the data, and so on and forth. It's not like always running. All right, so that's IoT. And then the third, I think, how about our time? Are we still good at for the time, Punikan?
I think we have still around 5 or 10 minutes, committee.
5 minutes. Okay,
Yes.
I'll go quickly. Margin pressures and need for new revenue. This is of course it's always a challenge for a company. And then supply chain disruption is a global story. We feel it in here in US. It's hard to buy cars these days, because just cars manufacturers, they have a supply chain disruption as well, especially for the chips. And then worker shortages and digital talent gap, right? Climate crisis and sustainability. All these issues are common. I mean, as we emerge from the pandemic. All right, so solving for smart products with over-the-air updates, AI at edge, fleet management, and more. So, like I mentioned earlier, with my previous customer who has the sensor in the ship, we have also the scenarios when combine IoT combined with the computer vision in a smart factory to that can do the inspection, visual inspection on the engine, on the machineries, or even on the output itself. Let's say in the past we have someone, let's say, to see, hey, this is the in the conveyor belt, the output has let's say the product needs to be this wide. If this a bit wider, then you have to discard it, or if it's shorter, you have to discard it. All of this can be replaced by computer vision, right? You decide that what you want to achieve, and with some toleration, and if it's not, then it will go, directed to the another line for discard. And then on the right here, create customer-centric omni-channel and personalized product experience backed with advanced analytics. So I don't know if you can see it, maybe it's just too small, but basically on the right here, it's just an example where you build a dashboard for the presentation of your analytic. So in this case, a company wants to correlate between the sentiment with the sales level. For example, you monitor the sentiment in the Twitter, right? You do sentiment analytics, you run sentiment analytics, monitor the Twitter, monitor all the tweets related with your product, related with your company, and then you score each tweets, it's positive or negative, and then you summarize it, put it into this dashboard, and then you cross the data with the sales, your sales level. So is this negative? If there's a negative, if there's a declining sentiment level, does it impact your sales level? Or if there's any lag, maybe 1 month or 1 day or 1 week after the sales decline, the sentiment decline, then the sales will follow. And then if armed with that knowledge, armed with that information, that you know what to do, the marketing maybe try to answer the complaint in Twitter faster, so it doesn't go down much, right? And also supply chain and operation optimization. Manufacturers need to gain visibility into their supply chain so that they can make faster decision. I'm sorry, any question? No? Okay.
No, not yet. But I think the time is around 4 minutes, Mr. Bambang.
Oh, okay. Yeah, so yeah, I think just open for the question and answer now. All right.
Okay. Thank you very much, Mr. Bambang. Sorry for rushing because we have a quite limited time this morning,
No
but
worries.
I think it's a very, very interesting presentation, especially a thing that nowadays is inevitable in our life, I think, about big data and also data mining. Okay, so we can continue to the next session, to the Q&A. Maybe we can see first some questions that already shared by the participants in Slido. The committee, can you please share the Slido screen so we can see the questions? Okay, seems the connections are still okay. Right, so we have several questions already, and we can start, I think, from the most forward one. So the first question is, what security aspects do we must concern most while using cloud computing technologies?
Yeah, thank you. Thank you for asking this question. I'm glad that you asked this because there are three things that the company everywhere, anywhere wants to do. First is to increase the top top line, meaning increase the revenue, sales revenue. Second is to reduce cost so that will impact the bottom line, the net profit. Or third is to reduce the risk. And depending on the where they are in the industry, which industry they are operating, the security can be very, very crucial, right? Like in the regulated industry in the US, like you are banking, you are in healthcare, life science, those are the regulated industry. And then the question is, what's the security aspects that we must concern most while using cloud computing technologies, right? So in general, when I talk to my customers, I would try to understand in which industry they are in. But in general, concerning with the data security, we have to make sure, and this is shared responsibility between the cloud computing provider and their customers, right? To make sure that the customer data are only accessed by the authorized system and authorized people, right? Because the if there's any leakage of the data, if there's any breach of the data, then it will be a penalty. Like I don't know how's the regulation in Indonesia, but this is the I'm talking from my experience in here in the industry in US. If you have a breach, you have to report as soon as possible to the regulator, and then you just need to plug the hole and then be ready to pay the hefty penalties. Of course, companies don't want to do this, so they have to work with the cloud provider to secure the infrastructure, to secure the data. And the good news is it's easier to secure the data in the cloud computing rather than the on-prem.
Okay, thank you, Mr. Bambang, for the answer. So maybe we can go to the next questions. Greetings, Mr. Bambang. It was such a great explanation. Could you please explain the precautions that a user must consider before going for cloud computing?
Right. Yep. This very good question also. So what the users must consider before going for cloud computing? So cloud computing is not one and all solution. So it could be that there are workloads that that cannot move to the cloud computing. For example, I had a customer who is a manufacturing company. It's I think it's what is that? Cattle food company, like makanan ternak ya. So they have in their factory, they have the like an engine, like a machine that controlled by the computer, right? So this computer has to have the very low latency, meaning that it has to stay, the computers, the servers, the software that control this huge machine needs to be in the same place to reduce the latency, right? The time needed to travel from the server to the engine. So of course, in this case, you cannot move the server to the software to the cloud computing regardless, because if you move it to cloud computing, there will be adding more time to reach the cloud, and this machine will stop working. So in this case, you do what we call it the hybrid network. You have the cloud, you have the on-prem, on the edge, and you only need to send the analytics data to the cloud, so that the cloud so that you can run modeling, machine learning, and everything on the cloud. But the controlling function still running on site.
Okay. All right. Thank you, So actually the solution not necessarily require everything in the cloud computing, but can also a combination within, let's say, the local and also the cloud computing.
Correct.
Right. Oh, great. Thank you, Mr. Bapa, for also enlightening me on that matter. Okay. Next question is from Camila Nurosha. What are the most significant issues in data mining of Google, and how does Google solve it, even though there is a huge amount of data?
Right. So yeah, since the beginning, Google has been working. We've been dealing with a huge volume of data, right, and variety, because Google has YouTube as well. There's videos, right? That's another variety of the data. So this amount of data has not been seen before, right? So Google has to research, has to invent it, had to invent ways to process the data at the beginning. So that's why when you learn big data analytics, you may heard about MapReduce, Google file system that predates the Hadoop HDFS Hadoop file system. So all these things were invented that time to deal with the big data. And then now we have the BigQuery in Google, which is serverless. You don't have to spin up a VM. You don't need to care about the operating system, is Ubuntu, Linux, or Windows. You just use it. Just upload the data, petabytes of data, and create a machine learning or any analytics for that matter.
All right, interesting. Thank you, Mr. Bambang, for the explanation. I think we can go for one or two more questions. Okay, this is, I think it's also interesting question from Sophia. What is the storage capacity of Google Cloud? Does it have a limit?
Yep, there must be limit, right? But when the limit is so high that then you tend to say, well, it's unlimited. Well, it's kind of it's hard to determine. But on the storage itself, compared to if you have the storage and the data in the server in your company, and this and the data in the Google Cloud or any cloud computing for that matter, is that how flexible to increase or decrease your capacity, right? Like I mentioned earlier, the flexibility, and also how easy it is to secure your data. You must have heard about the ransomware, when the bad actor injects the agent and then encrypts the data, right? This can be, I mean, not prevented as such. Well, prevention is another story, but can be restored quickly when the company back up their data into the cloud and then make it immutable, meaning that no more writing on the data. Data will be like put in a vault, meaning that even if the bad actor has access to the data, it cannot encrypt it because it's already locked. You cannot immutable. You cannot change the data, right? So whenever there's a ransomware, then the company will go back to their backup, immutable backup, and then restore these files, and then they can go back to the operation quickly.
Right. Right. Interesting also. I mean, I learned so much in this very short time from you, Mr. Bambang. It's very, very interesting to learn about this. Right. So I think we can have one more question from Moses, Elijah, San Pascual. Is the use of big data and its analysis solely for big companies like Google and credit card companies, or can small businesses utilize it as well?
Very interesting question. So I think it depends on the nature of the business. If the business even is small, but if it collects or have access to the big data, then it may use it, right? It may use the big data solution. But the thing is, you don't have, I mean, from the company perspective, you don't have to build your model, right? You can use ready-made model provided by the cloud provider, provided by Google, provided by Microsoft, provided by AWS, for example. We have the ready-to-use computer vision and language translation, for example. So we have trained the model in Google. We have trained the model for the language translation. It's not only word by word, but also by intent, right? It's not only word by word. That's very important. So rather than a company wants to train their model themselves, the data themselves, they can just use the solution from Google. This is like a build or buy decision, right? Rather you build it, you buy it, because it just cost prohibitive for you to build your model yourself. And why not? Because it's already been there, already been provided by Google. You just send the whatever. Let's say I have a sentences in English, I want to translate it to Spanish. Just send that to the API, to Google Translate. Google Translate will show me the translation. So it's the same thing like Uber or Gojek using Google Maps. Rather than they build like a Google Maps themselves, just use Google Map.
Right. All right. Yes. Very interesting. Okay. Right. Because of the time limitations, I think we can conclude the Q&A sessions. And because I will just do like have a very quick recap. So Mr. Bambang, thank you very much. You have explained to us what is actually big data and data mining. I mean, these two terms is actually, I think, commonly heard, but maybe not necessarily everyone really have an understanding about that, including myself. So thank you for enlightening me on that matter. And it actually can be applied to different kind of industrial sector. I mean, depending on the requirement or the characteristic of the business itself. And one thing that I also learned, though we can actually use the cloud computing, let's say, to perform the solution, not necessarily it has to be fully cloud computing, but actually it can also hybrid or actually a combined solution, right? Depending again on the problem or the company itself. Right. So again, thank you very much, Mr. Bambang, for the very enlightening material this morning. And thank you also again for sparing your evening with us. We hope we can hear from you again soon, maybe in a different occasion, hopefully. Thank you, Mr. Bambang.
You're welcome, and my pleasure. And if there's any other session next time in the future about the cloud computing, I'll be willing to speak more about that topic. So thank you very much, everyone. I wish you good luck for the rest of this summer camp.
Thank you. Thank you very much. Good evening, Mr. Bambang. And I return the Zoom to Emil and also Arthur. Good morning.
That concludes our fourth plenary session throughout the event. Before proceeding, we'd like to remember the participants to fill in the attendance form already sent to you by our committee in the Zoom chat box below. And next, we would like to express our gratitude for